Alright, so this last video for the section, I was going to go into basic calculus stuff that you guys need to know for calculus, but for the sake of time, I'm going to go over stuff that you actually need to know for the test and vocabs that you actually need to know in order to answer the questions, alright? So they'll give you some type of function like this, f of x equals 3x cubed minus 16x minus 2, right? They'll ask you to either graph it or they'll give you a graph, but either way, they'll give you one of these. The first question, it says write down the values of x where the graph of f of x intersects the x-axis. So if it intersects, that means it means something like where does it cross the x? And these are the x values that they want, all right, the x values. That's what they want for this. For B, they want you to write down f prime of x, all right? And if I were to write this bigger, that's f prime of x. And you guys can clearly see that on a piece of paper, but on this smartboard on the video, it's kind of small. Anyways, if you find the derivative, all right, what the derivative gives you is this. It gives you the equation to find the slope. Alright? So it doesn't give you the slope, it gives you the equation to find the slope. So what you do is find a derivative, plug in some x value, after you solve it out, simplify it, that's going to be your slope. Alright? So again, the derivative is not the slope, it's the equation to find the slope. Big difference here, alright? And you guys did that, I think on the homework or the classwork the day before, right? Find the local maximum and local minimum. So if we had a graph like this, right? The maximum point would be right here. The local max would be right here, right? In this case, because this graph goes up and this graph goes down, there's no absolute max. This continues on, so it's infinity, right? Local min is right here, as in because this minimum value keeps on going on, the local min would be this, all right? The absolute max would be negative infinity, as in it goes all the way down, all right? Keep that in mind. It's where the vertexes are, I guess, in a way. However, real quick, this right here, this has an absolute min, as in there's no more point lower than this, all right? Something like this has an absolute max, as in no other point is going to be higher than that point, all right? So there's a big difference between local and absolute, all right? Down here, let M be the point where the graph of f of x intersects the y-axis. In that case, it's something like right here, that's where it intersects the y. Only on the y value, it's your y-intercept basically, all right? What else? Write down the coordinates of M. That's just where it crosses the y-axis. Here it says find the gradient of the curve at M. Alright, so the gradient. Gradient means slope, right? So here, when we find this, right, we're going to plug in some x. So we're going to plug in some x to find the gradient. Or slope, as you guys all know. Alright? So that's how we find it. Don't get confused. You're like, oh, how the hell am I supposed to find that? Look to the derivative. The derivative is going to give you the slope. All right, plug in that x value, find the derivative. And simple as that. All right, and the last part, they're going to ask you guys, what is the equation of the line tangent to the point at M? All right, so let's say something like this. We have an equation like that, right? We have a point M where it crosses the y-axis. The tangent line is going to be this straight line that touches that point, only that point right here, right? They want to know what is this equation, and usually it's going to be y equals mx plus b, all right? Later on in like Calc 1, 2, or whatever, this equation will be a very different type of line, but in this case, it's always going to be this, I think. Well, for the most part, I haven't seen anything other than this, but they want this equation, all right? And how do you find that? You already found the m using the derivative. You already have the coordinates because they ask you to find the coordinates. Plug it in, find that b, rewrite it, and you have your equation. All right. So right now I'm going to go over how to find these answers exactly. I know I just went over the vocab, but let's actually do the problem. All right. So the very first thing is graph it. Simple as that. Grab your calculator and just graph it. All right. So we're going to plug this in. 3x cubed minus 16x minus 2, and we'll graph it. All right. So here we have this graph, but we can't see the top part, we can't see the bottom. So what I'm going to do, I'm going to change the windows. So the y values have to be increased, the y values also have to be decreased. So let's change the minimum to, let's say, 20, and change the maximum to 20. All right, that's not a 20, and let's graph it. All right, so now we can see it. I'm just going to do a little rough sketch. It's going to look something like, let's go green. Something like that. All right, not the perfect graph, but something like that. Let's look at that. Yeah, not too bad. All right, so we have that. What we want to find out right now is write down the values of x where the graph of f of x intersects the x-axis. All right, so we have our graph here, right? And I'm going to use this one just because you guys can see it, or it's more accurate. We want to know these points right here. All right, we want to know these points right here. In order to find that, we're going to use second trace, and then we're going to use 0. All right, so this is a common thing that we should all know. We did this in the beginning of the year. You should not forget this. All right, we want 0. We want this point right here. So the left bound, we need to go all the way over here. Press enter. Right bound, go on to the right side. Press enter. Enter. Guess. And we have negative 2.2 as our x value. Right? We just want the x values, not the whole point, but it's the x value. So negative 2.2. We'll round it to 2.2. Right? So you're going to do that for each and every single one. I'm going to write down the answers real quick. This is going to be x equals negative 2.2, x equals negative 1.2 or 0.125, and then x equals 2.37. Alright, so write that down because I'm going to erase it because I don't really have enough room to do all this. So write that down. You guys can find that on the calculator easy. Alright, next part. We want to find the derivative of f of x. So this is going to be the derivative of this, which is 9x squared minus 16. Alright, pretty simple. Remember, take this 3, bring it down to the front. 3 times 3 is 9. Subtract 1 from 3, you get 2. Same here, there's an exponent of 1. Take this 1, bring it down to the front. We have negative 16. 1 minus 1 is 0. Anything to the 0 power is 1. This changes to 1, but you don't have to write that. And the last part, negative 2. When you derive a constant number, it's just 0, and we don't have to write that. All right. So this is our derivative. This is the equation. Let me write that. The equation that gives you, or that gives the slope. Oh, forgive my English. So it's the equation that gives you the slope when you plug in the x value. All right. So please remember that. All right, now I'm going to erase this. Please write it down just because I don't have enough room, all right? All right, so the next part. We want to find the local max and the local min, all right? The local max, in this case, is going to be right here, all right? The local min, let's say local max. The local min is right here. And how do we find that? Using the calculator, right? So let's do this real quick. Second trace, we're going to find the maximum first, all right? The maximum is on this point right here, so left bound would be somewhere right here, doesn't matter. The right bound is somewhere right here. All right, so real quick, you guys see these two arrows right here? What you just did was you narrowed the field down to just this right here. You're telling the calculator that, look, the max is somewhere right here. Just press guess, and it's going to give you the answer, right? And in this case, it's negative 1.33, all right? Let's find a local min. Do the same thing, go to min instead. In this case, the min's down here, right? So left bound would be here. Right bound would be over here somewhere. All right, press enter, and that's your local max, or min, sorry. All right, so I'm gonna write this down just so you guys have it clearly. The local max is gonna be negative 1.33 comma 12.22, and then what was the local? So that right there, you guys can write that down. 1.33 comma negative 16.22. All right. All right. So the next part, let M be the point where the graph of f of x intersects the y-axis. All right. So what they're actually asking you is, where is the y-intercept? The y-intercept is right here. All right. They're telling you that that is point M. It's called point M. All right. What we want to do is find the coordinates of M. You can find that on the graph by doing this. Sorry, it's turned off. Right? You can go trace, plug in 0, and then press enter, and it gives you negative 2. Alright? Simple as that. Or if you wanted to easily do that on the function, you just have to plug in 0 here, and then it'll give you negative 2 anyways, all right? So 0, negative 2 is your y-intercept, your coordinate for M, right? The next part, we want to find the gradient of the curve at M, right? So remember, this we found earlier, I know I erased it, but this was 9x squared minus 16, right? I told you guys that this gives you the equation to find the gradient at the curve. So we're going to use that real quick to find the gradient, the slope at that point M, right? So x squared minus 6, right? 16. So what they're telling you guys is, at this, what is the slope right here? And let me just draw that. Oh, let's draw it in blue. What is the slope of the dotted line right here, all right? So all you have to do is use the x value, plug that in. So f prime of 0 equals 0 squared minus 16, and that equals negative 16. All right, this is your M value, your slope. All right, now we have the slope. We use the derivative to find that slope. This dotted line up here has a slope of negative 16. All right, so the last question here, we want the equation of the line tangent. So tangent means the line that touches the graph at a certain point and only at one point. In this case, we're looking for this line, this dotted line, touching the point at M. All right. So how do we do that? Again, we have a point, we have a slope. So I'm gonna rewrite those right here. M equals negative 16, the point 0 comma negative 2, because we want the tangent at M. We're going to use this, we're going to plug it into y equals mx plus b, all right? So a lot of you guys, you guys used the point slope form, which is y minus 1 equals m times x minus 1. That's fine, or x minus x1, sorry. But that's fine, use either or. I like to use it this way, so we're going to plug this in. Negative 2 goes in here. The slope is negative 16. The x value is 0. Plus b, this is what we want. So if we simplify this, we get negative 2 equals b. So our equation for this dotted line up here is y equals negative 16x minus 2. All right, so what the hell is this? All right, so this dotted line, this blue dotted line, has an equation of y equals negative 16x minus 2, and that's what we want to find. And these are the types of questions that they'll ask you. Please write the vocab words down, understand what they mean, understand what they're asking you, and that's basically it. All right, in class on Friday, if you guys are there, we'll go over Actually, I'll give you guys the take-home test so you guys can work on it. Maybe ask questions. Maybe I'll help you. I don't know. We'll see. All right. But please write down the vocab so you guys have that down. All right.